Okay, thank everybody for joining us in this lab today. Uh, Today we're going to be talking about how to use the Facebook Prophet to do forecasting in the WTI price of the crude oil price. So it's going to be a session in R, and they're going to end up doing an app. For those people that are not too familiar with R and apps and all the shines, this presentation might be a little overwhelming, but don't worry about it because the goal of the lab today is to show you what you can do using R and Shine and how to bring value to your project. In the next labs, we're going to be a little more for introduction and how to build an app from the scratch, focus on the data science project. So I'm going to share my screen and let's start it. So yeah, so today's lab is about the WTI crude oil forecasting using the Facebook Prophet. So just an agenda. It's going to be hosted by me, Marcelo Guarido. I'm a data scientist with a PhD in geophysics, and now I'm the head of the Cruise Data Science Initiative. And Daniel Thread, that is a professor and chair of the exploration geophysics at the University of Calgary. So the agenda of today, we're just going to give a small talk about what is the Cruise Data Science Initiative. You're going to go for a small demonstration of the app, so what you're going to be building today. We're going to talk about the crude oil price and what drives it, but we're going to be using basically a model that uses itself for the predictions. We're going to talk about the Facebook Prophet inside the model time package and how it works. We're going to go for a coding hands-on. So I'm going to present how you do the whole project from downloading the data and everything, and some closing notes. So the first thing I'd like to present the Cruise Data Science Initiative. Cruise is this consortium at the University of Calgary that we have a history working with seismic data. And now we have this data science initiative that focus on AI and all related projects. So we have worked like consulting and projects in geoscience for academic and industry purposes. We also give it training, like programming trainings in R, Python, and MATLAB, with applications for geophysics and also how to create apps. So those are more deep courses that you do than the learning labs. And also the learning labs, those are the presentations, the webinars are going to give you every 2 weeks. And you can access the previous ones by going to the Cruise website, which links data science. So if you click in this link, you're going to open the Cruise data science page. And it's loading. So, okay. Okay, so I believe that the website might be off, might be not working today. So, but you can access all the labs are recorded and you can access the web page and also the codes. So the codes that I'm going to be using today is going to be shared also in the website. So let's go first for the app demonstration. So that's what you're going to be building today. So this is an app that we built for the price of the oil using the Facebook Prophet. So this main plot here shows the forecasting that you have in red and the historic data. So we're going to be including buttons like that, like the data range that you wanted to use the data. So for the WTI, it's started from 1986, but here I just selected to 2005, but you can change that. You can select a different year to start. For example, let's start in 2000, just a date in January and the first day of January and until today. So if you apply, and then you're going to have the updated plots and also the updated the predictions. So yeah, so this is the data that we have so far, and you can zoom in and check how the predictions. Those are some metrics that you calculated based on the testing set. So for the testing set, I selected initially 12 months to be the testing. So we can select up to 24 months. So it's going to be the last 24 months they're going to be used as the testing. So they're going to do the prediction is done on the training, the rest, and then calculate the metrics over the testing, the prediction over the test. We have the seasonality that you can change for additive and multiplicative. Additive, I'm going to explain better, but the multiplicative, it's useful when you have amplitudes or the trends, they are increasing amplitude by time. And you can also select the horizon type. Here, in this plot, it's a monthly averaged data. So it's the average for the months of the price. We can select this to be daily, to be weekly, to be for quarter, for year, for months. So let's take a look for the weekly, and the horizon, that's how much you want to predict, is going to be in time units. The default would be 12 because the default of the time unit was months, so it would be predicted for 12 months. So if you want to predict 1 year in weeks, so you put 52 in here. So now let's do the apply, and you're going to have the new predictions in here. So in the background, it's running the model. It's retraining the Facebook Prophet model and also calculated the new predictions. And you see that the color here even changed. So that means that by the metrics that we have, it's not doing so well. So even the icons are going to change based on this testing. That's going to happen very often because of this very large drop that we had. That if you look in dailies, that was the months that you have 1 day with negative price of oil. That was the day that the companies were paying for you to get the oil. So that's never happened in history. So it was unpredictable by any kind of machine learning model. So I changed it here 2 days. So it's going to try to predict the next 52 days. And it's going to take a little longer. So as you have more data, the model takes always a little longer to update, but it's running in the background. So basically, that's what we're going to be building today. So I just want to wait a little bit here to show how is the daily data. So while it's running, and then we go back to the presentation. I think when you have another way to get some metrics that are good is when you remove 2020 from your predictions. For example, you could select here to not use 2020. I want to use just until 2019. So yeah, so this is the data that was updated now for daily. We see that it has a high frequency variability. That's the price vary by day. And actually, the training set worked better in this situation. I didn't change anything, just for daily. So that's something that you can create and do your predictions. However, when you look to the predictions daily, here, it doesn't look so good. What happened is because the Facebook Prophet is going to calculate actually the predictions for the whole period in here. And what it's plotting here, it's basically the continuation. So you see that here, it started a little on the top. So it's continuing from the top here. It's basically that's what's happening. But for the metrics, in this area, the metrics worked quite well. So, okay, let's go back to the presentation now to finish with the app demonstration. So let's talk about the price of the oil. So the WTI is the West Texas Intermediate. So it's the price of the oil that it's a type of a mix of crude oil. And a lot of things can affect the price of the oil. So this figure I got from this US Energy Information Administration website saying what can drive the price of the oil. So basically, is this website here. So it says that a lot of things can, geopolitical and weather conditions are gonna change what's happening with the price of the oil. So all those marks here, all those numbers, they represent some event, some geopolitical event that changes the price quite abruptly. So it would be like a change point. So for example, this one is the number 11. So what happened here was a global financial collapse. Here, the 14 was the pandemic, now the coronavirus pandemic that we have. The number 8 was when the OPEC cuts the production to increase the price. Here in the 12, again, was another cut of production from the OPEC to increase the price of the oil. The 13, when the OPEC didn't change the production at all, so the price kept going down. So, however, for our predictions, we are not going to be using this information. We're going to be using the Facebook prophet that's going to actually automatically try to calculate all these points. The data that we're being getting is from the EIA website. That's is from here. So that's an API website that you can get the API key, and then you can download automatically from your computer to your computer. This key we can download it directly from the EI website, but I really like to use a package in R named QuantL that's going to download it from this website named QuantL. This QuantL has a lot of financial data sets in here and also the price of the oil. So when you use this key, that's the one that you're going to be downloading. So if you want to use the QuantL, you have to create an account and generate a key. So that's the QuantL code that you're going to be using in R, actually. So we have the libraries for R, for MATLAB, for Python, and I'm going to be using the R. I'm going to show you in the codes how to do that. So for the forecasting, we're going to be using the Facebook Prophet. This is a model that tries to predict the future by using the on time series by itself. So it's going to make a decomposition of this time series. So the main compositions for this example are the trend, how the very low frequency of the data is changing by time. We have the yearly component. That means how the data varies yearly, every year. We have the monthly, also how the data varies for each month. We can have also weekly. You can also have daily. So what's going to happen? The Facebook is going to sum or multiply in a way, if you select additive or multiplicative, but the goal is to sum. So you're going to get the trade, the trend, that's the trend for the whole time series, is going to get for each year here, repetition for each year, is going to sum the yearly repetition that you have here. For each month, you're going to sum the month's seasonality for every week, for every day. You select that. And those vertical red dotted lines here, dashed lines, those are the change points that it calculates to do the trend. So those are basically the same change points that you have here. It's going to try to calculate, to identify the change points that make an abrupt change in the trend of the time series. You can access also the web page of the Facebook Prophet. That is this one. It's a GitHub web page. So you have the package for R and for Python. We're going to be using the R in here. And you have the Get Started. So you can come here and check how to install the library, how to update, how it's going to work. You can have all the parameters, the explanation and how to change. And what I'm going to be doing, I'm going to be using another package named Model Time that it groups a lot of different forecasting models, even the profit. So what I like about this package, it's basically that. You can try different forecasting models and run at once, actually. So in the coding, I'm gonna be even showing the difference comparing with a Arima model, a simple Arima regression. So when I'm using the profit for this model time package, we have to call the profit regression or the profit boost. So the profit boost is gonna be combining the profit with a gradient boosting for the residuals, but in here, I'm gonna be using just this regular regression, and they're gonna be comparing with the Arima. So we have different ways to do that. So what you can do now, we can go start for the coding. So if you go to the R, now we have the R Studio downloaded here. So first I'm gonna demonstrate how I calculated every step, and by the end I'm gonna show you very fast how is the app working here to create that app that we showed before. So the first thing that we need to do is to load the libraries that you're going to use. I like to separate each library in here for each type of function that it's going to be doing. So for example, the API, the one that's going to be downloaded, I named it, I put here, that's the library quant_l. We have the ones for the time series, that is lubridate, that take care of dates, and time TK, that it's a time toolkit. So you can have a different plots and different ways to work with that. We have the visualization, that's the plotly. Actually, the GG core plot I'm not using. I'm gonna actually delete it. So I'm gonna use the plotly, that's an interactive visualization. And for the core, I'm gonna use tidyverse for the data wrangling, tidyquant, that's very also useful for this wrangling, and data table to take a look at the tables. But I believe that I'm not using that as well. And for the modeling, we're going to be using the tidy models, the model time, and the profit. So to load all those packages, I just select them and press Ctrl Enter. So you're going to see now that my console is going to be loading each one of the packages. So now the next step, the first step that you want to do for this is actually to download the data from the quant_l website. So when you have access to the code, if you try to run this code, it's not going to work for you because you have to create and add your own key here. In my case, I saved my key in my R environment, so I'm just calling the key here. So this is a way that I'm not showing my key. So, but you can just uncomment this line when you have a code. When you have the key, you can comment this one, and you just add your key here between quotes. But let's comment this and then comment that. When I run this line, here you see that it run in the terminal. What's happened now is that now the quant_l knows that I'm logged in with my account. So we have that EIA code that I showed in the EIA website and the quant_l. So I'm just saving here as a text, as a char. And here is the quant_l package, the function that I'm gonna be download from the EIA code from this key. I'm gonna be downloading the data that's starting from the first day of 2005 until today. This is a function from the lubridate package that gets the today. If I just run this, for example, it's gonna get today's date. And the order, I'm saying that's ascending. So it's gonna be from ascending organization. And this is a pipe that's coming from the deeply R. It's a package that's also loaded when you load the tidyverse. That means that I'm connecting the output of this function to this next one. So what I'm doing here, I'm sending to this new function. What I'm doing, and this function is converting this downloaded data that's downloaded as a kind of matrix to a table. A table is a data frame in R. So when I just run this command L, that's what's gonna be downloaded. So we have this data set downloaded that we have the date and the price. When I do everything like that, with the stable also included, now we have a table, we have a data frame. So we have this first column that is recognized as a date and the second one as double. So I'm gonna run out all these. So I'm gonna save in these WTI prices. So now it's saved here. You can even look if you want. You can click here. It's gonna open your table in another window. And here I'm using the package timeTK to plot the time series. So I wanna plot what we download. So those are just a bunch of parameters that you get. I'm doing a smooth. So let me show first the plot so you can understand better what I'm doing. So it's gonna pop up here on the side. Just gonna make it a little larger. So this is the time series that we download in black. In blue is this is smooth. So it's just we just did a kind of a regression in here and make a smooth representation. And also the plotly slider, that means that we're getting this one. So those are very easy ways to do plots when you use the correct packages. In here, down here, it's commented, but it's something that you can try at home. If you download the data and you subset the data that you downloaded by removing 2020, because these 2020 predictions are going to be very hard to work with. But we are not going to touch this today. We're going to show you that you can do that in the app. So the first thing that we are doing to test our modeling is to separate the data, to split into training and testing data set. So I'm selecting to be 12 months that I'm selecting. This is a package this is a function from the model time. And I'm gonna take this WTI price and I'm gonna create an object named splits. So it's gonna be 12 months. The last 12 months of the data set is gonna be used as training. And this cumulative means that the rest is gonna be the test, the training, sorry. So if I run this, without the split, so we just create an object that has the splits. So we click here. Now we run this part. We created the split. You can see that's a list of 4. So it has a bunch of information in here. So now what we can do is to plot one above the one together with the other. So we get these splits. We send to this toolkit time series CV plan. So that's where we are gonna be separating the data, the training and the test data, and then plotting. So by doing that, we're gonna have a new plotly representation of this time series. And now you can see that how the test is separated. So the red is the test and the black is the training. So what you're going to be doing now, we're going to be running our model, training our model in this black data and try to predict and see how well we did compared with the red one. So now to train and to fit a Prophet model is quite simple to do in the model time. I mean, it's easy to do. We use this function named Prophet regression. We have to select the mode that you want to do. You want to do regression. We could be doing also classification, because this is the way that is done in the package tidy models. But for Prophet regression, we don't have another model, another mode that's not regression. I'm just including here to be very equal to the others that you use. The growth that you're using, I'm selecting linear growth. You can select logistic. This is the number of change points that I'm setting here. Number of change points that a Prophet's the maximum number of change points that Prophet's gonna try to find in the time series, where you have that changes of abrupt for the trending component. I want to do the season. I want to be the additive, so I want the prophet to be adding all the components. So after that, we pipe and we send to the engine. So let me just run this first. So that's what you created here. We just created a model with the parameters. In the second one, we're going to set the engine, which package that we want to use. So I'm using the prophet package. And if I want to include, and I'm removing the weekly seasonality. So I don't want it to use weekly seasonality. So it's going to be using just yearly and monthly seasonality from now on. When I do that, it's going to also create a new model with all those parameters. Again, it's going to include these other parameters and also which package I'm running from. And by the end, I'm just fitting with the training data set. So it's going to be the training part of the splits. And this is a function that you created. This is I'm going to be calculating the value in function of date. So if I run this line now, I'm going to be running, creating, and training the model. So here, it's just going to take a few seconds to run. And after that, I'm going to show what was created. This is an object created that already has all the predictions calculated. So it's going to take a little bit. So that's what was created. So the fit time, it took 20 seconds to fit. That's quite fast, in my opinion. And here, just for a comparison, how it works, how the prophet works, I'm going to be comparing with a Arima model. The Arima is the auto regression integrated moving average model. So what it does, the auto regression part, means that it's going to be calculating the regression over delays of this on function. The moving averages means that you're not going to be doing for daily, but also for an average of a period that you're including here to be the week. So it's going to be an average for each week. And the I means integrated is to take care when you have non-stationary time series. Stationary time series is when you have a time series where when you move into time, the distribution keeps the same. In non-stationary is that the distribution is going to change over time. So this integrated, a way to handle with that is instead of to do the regression over the values of the price, is going to be a regression over the difference between one date and the other. So the difference of the value of the day minus the previous. And you can do this several times, it can be several differences. So that's the same way we do the model regression. We set the engine to be the Arima, and we fit, and we're gonna have, if you run all these, now we're gonna be the Arima model, also trained, and those are all the weights that we're gonna be using. So for the model time, to be very fast to run over the testing, all the models, we can create a model time table where we're gonna include our different models in one single table. So when you run this, so now we have a table where you have the model ID, the number of just an ID that you can use to remove or include later. The model, it's a list that we have a bunch of information actually inside here. That's the fitting and everything, and the description. So now we're going to run over the testing model. So you do a calibration. It calls calibration. So we're going to get our models table, and you're going to do the model time calibrate over the testing part of our time series. So basically, we are running and calculating all the metrics in here. So we have the calibration data in this part of this table that includes all the metrics. For example, if you just take a look, you have this calibration, oops, calibration, calibration table, and let's take a look in this dot calibration data. What is it? So this is a table that includes all the predictions and all the residuals. So now we want to check how well we did. So the first thing, I'm gonna plot the predictions over the test for both models, and that's what we do. We do the model forecast for the actual data, the WTI prices. So it's gonna calculate the prediction over everything, and then you're gonna see how it did compared to the true one. So now we're gonna run these. You're gonna be creating a new plotly image that we're gonna have both models in here. The red one is the profit, and this green one is the Arima. So if you zoom here, apparently the Arima is gonna be most of the times a little more linear. For this training set, apparently the Arima is gonna have better metrics because it got closer to the true values. And actually for the Facebook profit got just a little above it. But what you're interested in to see after as well. So just let's take it. So that could be fixed actually if you don't use the 2020 because of this big drop here. It might be moving the whole data. Or actually, if you don't use the data from 2005, you can use it just here from 2015. So there are different ways that you can try to see and see how you can make better predictions. But we have to go back in the coding and keep changing. So I'm going into that. So now I'm gonna just show in here, that's a table that I'm gonna show all the metrics for each one of them. So Arima got better metrics for this example and for this way that you're doing the data. So now you're doing a recalibration, so you're gonna now be calculating the future. That's how we do. We refit the model for everything, and then we do the model forecasting for 12 months in the future, and the data that we're using to calculate the forecasting, and plotting again. So if I just run this part, again, I'm just gonna have a new plotly with the new forecasting part that now we're gonna be checking the future for both the Facebook profit and for the Arima model. So it might take a couple seconds to finish this. And let's see. And also here, after that, I'm gonna be showing how to do for other time units. For example, what you're using here is the daily price of the oil. We can use a function to change the time unit, to group the data into months, to get the average of months, to get the average for week, and so on. And we included that in the app. So it's gonna be nice for to see how you can do better predictions. So now we have the predictions here for the future data set for the daily price of the oil. So what happened for the Arima is just continuing as a continuing value after this day, and the profit is changing some variance after that. So now let's see if you can make a little better. Instead of using the day, you can use monthly. First, we're gonna be creating a function. That's how we create a function in R. We're gonna call, the name of the function is set time unit. So it's gonna be the function. Those are the input parameters. So it's gonna be the data. That's gonna be a table. It's gonna be our price. The time unit that you want to be using for be averaging the data, and the function that you want to use. I'm using min. You can change it to max, to mean. You can change it to median. You can select different values for that's going to be the representative of that month. So between curly brackets, the output is going to receive the data, and then you're going to mutate. You're going to be creating a new column that's going to get the floor date. So it's going to be the floor date means that the first day of each month. So in this case, for the time unit. So it's going to be rounding the dates for all of those days to be just the same day. So then you're going to group the data, and then you're going to summarize, create a new column named value. That's the same that we have there. That's going to use the function that's going to be the mean of the value for that month. And then we're just going to ungroup and do the output. So let's see how it's working. So now I created the function. You can see now the function exists here. And let's do that in here. So we have the WTI price, and then let's run and see how the table is now. So that's it for the first. So it's gonna always set to the first day of the month. So for the January, we have this average of the price of the oil. So it's the $47.4. For the February, March, April, and so on, and you have it for all the years. So now it's gonna be, and here I selected to be the median, not the average. I'm getting the median, just to show that you can select the different ones. The default, if you don't set these, it's gonna calculate the mean, but you can set the different ones. And also the time unit, the default is gonna be months, that you define it here, but you can change it to week, to year, and so on. So now let's plot the time series. So we're gonna create this new table, and that's the WTI new time unit. Let's plot this. I'm gonna again have a new profit, new plotly. So now you can see that it's a little smoother. And it is one I select to not have this smooth one. So it's interactive. So we still have the plotly slider. You can change that. So another function that I'm creating here is to calculate to plot the splits. So I'm creating these functions because I'm going to use later in the app. So it's going to also be including the data, and the ACES is how much I want to be the splitting in month. So I'm going to receive the data as we did above. We're going to have the time series CV plan that's going to separate the train and test and the plot. So when you do that, we can actually do something very nice. When you have here, after I created the function, I can put one function after the other. Here I'm having the new time unit, but I can use simply the WTI prices. That was the initial one. So I can set a new time unit. That's going to be this function that you created above here. So as I'm not including anything as parameters, it's going to be set into months and calculate the mean. And after, you're going to be plotting the time series. And they're going to be creating the splits. That's the time TK function. And then plot the splits. So when you create those functions, we're going to make the code very cleaner to read. So when we do that, from the initial data that we had before, now you're going to have this plot. Cool, right? So now let's continue doing our work. So let's calculate the splits for this new data set that is set for the time unit for monthly. So we have the monthly median in this case. And let's retrain our models. So I'm just going to select everything. I'm going to do the same thing for the Profet and for the Arima model. but now we have a different data set. Just creating the models. Here, just recreating the model time table. So that's the new model timetable that you have here. That's basically the same as the previous one. Now you're going to be recalibrating the model for the new type of data set that you have, the median of the month. So when you run that, I think I didn't run. Yeah, now I'm running. So no, I had run. So we recreated all those tables. So now we can redo to calculate and do the predictions over the testing and see how it worked for those median data. So it's gonna pop up here. And now I understand that Prophet is doing quite a better job, but again, it's very hard to compare when you have this part in here, that's the 2020, and this is the Arima, that is still always going to be linear. So now, if we check the metrics for this new one, so actually now the Prophet has better metrics in the total. So now what I'm going to be doing here is to create a function that's going to be fitting the model. So instead of to run all these every time, I'm just going to be creating this function that is just a repetition for the Prophet. So the function is going to make fit test. So here is just going to be for the Prophet. Here we get compare with the multiplicative and for the additive. So we got the splits. The data input is going to be the splits. So we're going to get the fit test, and then we calibrate, we do the forecasting, and we are plotting. So when you do that for the multiplicative now option for the seasonality instead of additive, you're going to have this prediction. And when you have the additive, it's going to show the next plot a slightly different prediction. So I can go back and forth with these arrows. So that's the additive, the multiplicative, the additive, multiplicative. You see that there is a small change mostly in the end here. And also the amplitude is different for the additive. So we can again recalculate for the whole data set and do the new predictions for 12 months. So as you see now that we changed it for the monthly time unit, it's calculating really faster. So now we have, let's just give a zoom. We have the Arima and the Prophet. So now I understand that the Prophet is doing a better work for this scenario. So you see that I created those functions. So the idea is that I'm going to be saving all those functions in one file named utils.r. So when you go to the files here, we have this folder named scripts. So you see I have these units.r created here. So let me delete this just to show how it works. Okay, so I'm using this function named dump. And then I'm going to be including all those the name of the functions in an array and where I want to save the file. So when I run this, it created this file. When you open it here in .r, those are the functions that it created. So that's just a fast way to save all your things. You can do all the tests in here, save your main functions in here. So now we can go to the app and take a look. So for the application, what's the advantage to use the application? You see that if you want to have better predictions and to understand better the data, we have to change the time that we're starting. For example, that's a way to test and see if you can get better predictions. But if you want to do that, we have to go again back to the beginning of the code and select the date that you have to do and run everything. The app is allow us to create a workflow that you just change the parameters in the app. So for the app, that's going to be this app.rmarkdown, RMD. I'm using the package Flex Dashboard and the runtime in Shiny. So this means that I'm going to be using Shiny in the background of the Shiny dashboard, in the Flex dashboard. So as before, what we do in this app, you're going to be creating the cells or the chunks. In Python, it's called cells. In R Markdown, called chunks, where you're going to include the code. So we're going to include the same libraries, and also I'm going to be sourcing that script with the functions there. For the Flex dashboard, we have to select how we want to be our app, the orientation. So it's going to be in columns or in rows. We want to do the vertical layout to be filled. So you're not going to be larger or smaller than your screen. So the CSS means that I'm getting the cruise style, a CSS file that's going to drive all the layout of the app. So it's a file like that. So if you go back here, we go to the folder CSS. We have this style.css. When you open, we have the CSS code. So this one, for example, I'm changing how the navigation bar changes in color. So I included a gradient color that goes from one lighter blue to a darker blue. And I also changed the brand, means the logo, not the logo, the title of that you're going to be including there. Here I'm just selecting the headers and so on. So we're going to be explaining this better in the lab 3. And also we're going to be including our logo. That's the cruise logo that we have in PNG, and so on. So the first thing is that you have to set in an app. Let me just run the document here again. So it's going to appear the app. So I'm just going to increase a little bit the size of the viewer window. And let me just hide this. So that's the app we are creating, the same one that we demonstrate in the browser. If you wanted to see in the browser this app, you just click in this button. So it means show in a window. So it's going to open in the browser. So we have a lot of things in here. We have this sidebar, we have this first column, and this second column. And inside these, you have different elements or different blocks that you call HTML. So how do we separate what is sidebar, what is column 1 and column 2? Using these dashes. If I want, you see that it's going to appear here when I have my coding outline, the document outline. That means that I have a new session here. So this session is going to be one column. But I put here, I included here between curly brackets, the dot sidebar. So it means that everything that's going to be included in this area is going to be included in this sidebar. So, and how it knows is by this dash. Actually, if you just have 3 of these dashes, it is still see as a session. If I remove to 2, you see that it's removed. So it doesn't know it's a new session. So if you include at least 3, you have that. I like to include a lot, so it's visually better for you to see when you have a new session. Another way, instead of use this dash, you could use twice the pound and also recognize also as this column. But again, I prefer this lot of dashes. So I can see very clear where I'm starting. So here I'm including the sidebar. This is the area that I'm using the Shiny JS. So I'm going to have also JavaScript running in this app. And that's how I start to include stuff. So this div command, it's actually a HTML command that indicates that you're starting a block. So what this block is doing is just creating this about the app. It's just this small information in here. So I included an ID, a class, that I mean that's going to be center, the text. So I included a h4, and that means a header 4. We have the header 1, that's going to be the larger one, that's going to be the header of document. The header 2 usually is for the section. Header 3 is for a subsection. Header 4 is what I'm using for this. So strong, it's also another HTML command that means bold. So about the app, so I'm including, what is that? So I'm including this A. This A is also another HTML tag where you include a hyperlink. So I'm in reference to this GitHub webpage. So if I click here, so it's going to open the forecasting for the prophet. So let's go back there. So when I included this target and the between quotations underscore blank, means that it's going to be open in a new tab. If I don't include that, it's going to open in the same tab that you are. And what I want to be the text that's going to be creating, that's going to be this blue one, that's going to have the hyperlink, and so on. So this HR means a horizontal line that I'm including here. So another div class, I'm including this. So for the buttons in here, you have different ones. For example, let's go to the libraries apps that you have here. You have the library Flex Dashboard, that I'm going to create this whole dashboard. The Shiny, that has all those commands in HTML, and also some very interesting buttons that you can include. We have the Shiny JS to run JavaScript, and Shiny widgets, that's a complementation for the Shiny to have different type of buttons. For example, this button here is a date range input. That's going to be this part here. That's going to be selecting the date. So I have to include an ID, because when you include an ID, so how the input here is going to be used in the whole app. So I'm going to be calling for this ID. So this label is just the title. So I just put like a starting date. So that's going to be selected in the beginning. That's going to be appear by default. The end, that's going to be today. The minimum, so the minimum that I'm including here is the minimum that exists for the website, the QuantL, and the max is today. And the standard view means year, means that when I click here, it's going to be appearing the year and the month. I can select months. So if I select months for the start view, it's going to be in this kind of a view. So this is how we include all those buttons. So we have the speaker, input, and so on, and I'm including all those buttons in here. So that's the sidebar. And also here is where I'm doing all those parts of calculating the forecasting, where I'm using my key in here. So the prices, so the event expression, I'm going to use the input apply. That means that this is just going to run if I click the apply button, and that's what we call the event reactive. And the expression that I'm using here is this function to the QuantL to download the data. So you can see that the starting date is going to be the input, and date range, that is the ID that you created for this button, and it's going to be the first input, that means the left one, and the end date is going to be the date range 2, that means this one, and the same thing that we did in the R code. So here you're going to be creating a new column, so that's the data width, like we're going to be including as 600 pixels. You can imagine this one as having 1000 pixels. So 60% is going to be this column, and the second column is going to be 40%. So, and that's how we created the app. So all those interactive and changes that we can do there. So we click here, You're gonna open in the browser. So it's gonna be easier to make calculations now to make new predictions. So by default, it's gonna run the predictions when it's loading with the default values. So now those are the forecasting for the future, and this is for the testing. So let's do something. Let's just start and calculate from the, let's remove 2020. So let's go from December 31st and just do the apply. So how would be the predictions if you didn't have 2020? So it's still calculating a drop. That's good, actually. But does it seems to make sense when we look for the testing, because we have all those information before, so it's trying to calculate. So let's start from 2015 in here. So we go here, we change for the 2015. So January 1st, and then let's do the new apply. So see, now it's fast, and we are also getting actually even better metrics. So that would be the predictions if you didn't have the 2020. Now let's include the 2020 back. So let's include today's date. Let's gonna apply. So that's what you can be testing with the app. So it's very fast what we can do. So yeah. So let's do now for week. So you see that now the metrics are not very satisfying. So let's do 4 weeks. So let's try to predict the next 52 weeks. And for the test size, let's keep 12, just to see what's gonna happen. And when you do the predictions now, that's what you're gonna have. So we have over the testing, it's doing that, and it's decreasing the value by time. We expect that's not true, but that's what's being calculated. If we try, for example, for the daily, for these amounts that we have here, we can now see how the predictions are going. So if it's going up or down. So it's still, oops, I want to put for the whole year. I select. So when I change the time units, I have to change the number of time units that I want to predict. So if a day, if I want to predict 1 year, so 365 days. So just to see better, but you see that it's decreasing in the testing here. The test is not going to change. The only thing that's going to change in here, it's also decreasing. So, but then again, you can try different combinations in here and see if you can get better predictions. So now I think we are done with the coding, with the demonstration. So some closing notes. So for people that, for you that don't have experience in this kind of programming, it might be, again, a little overwhelming, but that concludes actually the first block of our learning labs, the block that we are demonstrating what we can do and what you're going to be doing during these labs. So now we're going to announce the next 2 labs. So we're going to be calling the Shiny app customization block. So the next lab in 2 weeks from now, it's going to be the fundamentals of R and Flex Dashboard plus Shiny for data science. We're going to be showing from the scratch, from zero, how to create an app using the Flex Dashboard. So how to include the buttons and how to do. So it's going to be a little more hands-on. If you want, you can even be trying to be programming with me. And if you don't want to, only want to be pay attention, it's going to be recorded and you can try later. And in the lab 3, it's going to be an introduction to HTML, CSS, and Chrome Dev Tools for the Shiny apps layout. So we're going to be showing how to change, how to create the CSS files with the help of the Chrome Dev Tools and an understanding of the HTML to change the layout of the app that you're going to be building in the lab 2. So another thing that I'd like to be comment is about a lot of times I get these questions. So what do you want to use for data science? for to build your applications, everything, R or Python? My answer is you go for whatever you like better. In my case, I'm a little more comfortable with R, and I really like the RStudio IDE. That's the one that you're using, where you can create very fast, shiny apps. We can do the visualization very fast. So we have a lot of integration. So, however, you can do all those apps and all those kind of documents in Python if you use like the Streamlit. That's the package, that's the similar of Shiny ER, where you're going to create some apps. And the Sphinx is the one that can create the documents in HTML or PDF. That would be the one that's the same in NitR or R. So we have a lot of, you can do everything in both. In the case Plotly, I put here in the middle this package because Plotly you have for both R and Python. And another thing that I like R a lot is because of this package here, namely Reticulate, that combines the Python and R in one code. You can call Python from inside R. And I think that's gonna conclude our presentation for today. So if you have any question, please, you can just send a message with your question. So let's see, we have the chat here. Okay, so do you have any questions for now?
Marcelo, I just want to make a little comment about the difference between R and Python. One thing you will see often more R-oriented when you are doing more interactive things. If you're thinking of, for example, things that need computation, for example, in a computer cluster, right? Then you will often see more Python, and it's kind of yeah. I think you can do certainly both in both, but for one thing I noticed in discussions and courses with Compute Canada is normally when you are doing a computation in the cluster, they write a Python script that you can submit and basically log off from the system. System is calculating without the graphics interface. And normally when you want to do something like that with R, you open a cloud interactive section that implies basically you still can run in the clusters into the calculations, but it's a kind of a different procedure a bit altogether.
Okay, I agree. So yeah, so I believe that you're gonna have a lot of different labs. So in the future, you're gonna be having also different applications. The next two labs is gonna be more like how you can follow the labs. So again, all the labs are gonna be recorded and you can access. If you miss it, don't worry, you can access by the next day in the cruise website. And after you can take this as like a small course that you can learn how to do the applications. So if you don't have, I believe that you don't have questions. If you have questions, please just send a message. Just gonna wait a couple seconds. If you don't have actually any questions, I'm gonna stop the recording here now, and maybe you can talk after. So stopping the recording. So thank you for joining. And if you have any questions, you can contact me or Daniel by email. And see you in 2 weeks.